large-scale Vallisneria americana restoration in the Caloosahatchee River Estuary by Dave Ceilley. But then let's mention the next, the purpose of this. Okay.
Yeah, no, I put the presentation together, but there's a lot of people involved in this project.
Okay, let me present just the purpose of this is to share the project update and the success of restoring submerged aquatic vegetation in the Caloosahatchee River. And yes, the connection is with the priority, protect and restore and monitor estuary programs. Thank you. David Ceilley.
Everybody still awake?
Oh, yeah.
Okay, now we're going to talk about the orphan stepchild of the seagrasses, Vallisneria americana. A lot of people, well, some people call it eelgrass. USGS calls it wild celery, but South Florida Water Management District calls it tape grass, and that's what we're going to call it today. It's a long story, so I'm going to try and get through the history really quickly, but back in '93, a guy named Alan Hoffacker, who ran a company called Dexter Pender and Associate, was hired by the Water Management District. I think he volunteered to do this project. Basically, he's an avid fisherman and wildlife photographer, and he did this mapping when he was quoted as saying that the water was gin clear. I don't know if he's a heavy drinker or, you know, I would have just said he's clear. But anyway, sorry, Alan, he put together this really comprehensive map, and back in the day, you had to take black line aerials out and draw these things. So he actually took his boat out and drew in these lines here and then mapped everything as dense, moderate, or sparse. You can't really see here, but I had an actual hard copy of this map, and we had a grad student digitize it. The Water Management District, next slide, but this goes all the way up the tidal part of the Caloosahatchee. So we kind of left off down here. Now we're going up the river. And what you see here is all the different species of grass. This was Tim Waberman, the Water Management District did this, but my grad student, Daniel Dickerson, did this map, which is just the Vallisneria, just the tape grass. I would have had him recolor this dark green, but the red here are dense grass beds. There's the 41 bridges. This is the midpoint bridge. This is Whiskey Creek. For those of you, I live right down here. So, you know, this is basically dense grass. We had 1,200 acres plus or minus of dense Vallisneria beds in the river back in the 90s, early 90s. And this was a map I put together trying to get some Restore Act funding unsuccessfully. That's a whole other story. But anyway, so this is what we used to have. This got wiped out during the shared adversity, starting with the shared adversity discharges. There's been a lot of efforts by various organizations to restore grass. I think I was involved in the first one with Steve Bortone. At the time of the shared adversity discharges, I was working at SCCF. I was actually a restoration ecologist, also acting lab director at the Marine Lab. We actually had a Marine Lab back then. I had 2 employees, Jim Lacasio and Paul Ruderhouse.
Hey, Dave.
And yeah,
Can you explain what the shared adversity is? I'm not.
that's what the Water Management District and the Corps of Engineers decided to call it. Basically, they needed to dump a lot of water out of the lake.
Was this during the
Very quickly. It
El
was
Nino?
this time of year, during the peak of the dry seasons, the worst time of year to dump this stuff. So it started in March, went all the way through April.
What time frame? What years?
This was 2001.
Okay, thank you.
So this whole system here became a blue-green algae soup. Ernesto and others, like I said, I saw it firsthand. Every time I drove back and forth, you could see it. Killed off the blue crab fishery, shaded out the Vallisneria tape grass, caused all kinds of problems. Then they said, oops, we let too much water go. We're expecting a dry season. And there was a drought in 2001 that persisted for quite a while. Dr. Bortone had done some work with the Water Management District and had some monitoring stations here. He actually found that grass grew better in clear water, even if the salinity was slightly higher. Anyway, I digress. Next slide. So basically what we're looking at is freshwater system dominated by Vallisneria, tape grass, blue crabs. Further down, 15 to 20 parts per thousand, you have the oysters, and then you have the thalass. So this, you know, Vallisneria tape grass is at the front end of this whole thing. So it's receiving the brunt of this. With the loss of those grass beds, we lost that filtration. One of the reasons I think, can't prove it, I think that's one reason we have more losses of grass downstream and red tide events. So restoring this upper end or the front, basically the front lines of the ecosystem is really important. Next slide. This is put together by Dr. James Douglas at GCU. He's one of the guys that's been working on tape grass restoration of the river, along with Dr. Bartleson at SCCF and others, Moat Marine Lab. Brad Robbins did some work. And so a lot of people have tried to restore this, but what's really interesting here, this is the shared adversity discharges that then they cut off the flow in 01. And we see Vallisneria density dropped. Okay, we had some wet years in 05 and 06. You see salinity was very low. This is in downtown Fort Myers. And tape grass started to recover. How did it recover? Well, let me pass something around to you. I have a single seed pod will produce about 300 seeds. Go ahead and pass that around. These things can persist for years in the sediment, possibly decades in a dormant state. When the conditions are right, when salinity is low, grass came back. But guess what? In 08, we had another drought. Boom, 1-2 punch. So we lost the grass and basically was flatlined for quite a while. Several studies were done during this period of time. We're going to go ahead and jump ahead to the next slide. But anyway, we lost a lot of this stuff. So what are the factors controlling? Yes, obviously blue-green algae shading it out, but also salinity levels were a real problem. We know that for sure. There were some mesocausing studies done by Peter Turek and Bob Chamberlain. Water clarity, like I said, Dr. Bortone, Steve Bortone and Robert Turpin did some work on that. I know there's been some work done by Rick Bartleson on temperature tolerance, sediment type and nutrient concentrations. This was published by Lynn Geddes and Bill Haller at UF. And in 2003, it was 20 years ago, right about now, there was a conference held at Moat Marine Lab. And what we found, as soon as we planted this stuff out there in the river, it was grazed down there today. So quickly, we had to modify our experiment. Now, at this time, I was down at the Conservancy of Southwest Florida, working there on Steve had switched positions and gone up to SCCF as the new lab director there. They got some funding. They were able to afford him and they started the lab, and it's continued to grow since then. But several studies were done. SCCF did some work. I did some work in 09. So we're going to jump ahead to 2018. Actually, this is a grass bed that was restored in the upper part of the river. It came back after putting the cage on it. That's another story. Let's fast forward here. Almost. Okay, so in 2018, recognizing that herbivory was a problem, we did some work in the upper part above S79. And what you can see here, when we remove the exposure cages, this is what happened. It just got raised down to nubs. What was this long became this. Working with Dr. Everham, Carter Henning, and Jim Anderson on this study, we used their patented exposure cages. Next slide. So we're upstream of the Franklin Locks, trying to establish a seed bank, recognizing that herbivory is a controlling factor. These are 4 sites we looked at. Next slide. And by God, we were able to grow grass like crazy inside these cages. We even had Nymphea come back inside the cages, nothing outside the cages. And in this case, it was the one of the controlling herbivores was the Pomacea maculata. It's an invasive exotic apple snail. Limbkins and snail kites love it. So it's helping them, but it's also decimated SAB. Next slide. Inside the cages, we did basically actual counts, over 1,000 shoots per meter square. It's just crazy. Inside the cage, outside the cage, it's 0. Next slide. Just another demonstration here. Another study I did in 09, put a cage out, took it out after a year, came back in 2015, 6 years later, put a cage on it. This is what we were able to grow. Outside the cage was grazed down, but the rootstock was still there. Just to emphasize that now. Friends of mine were saying, oh, it's all water quality. Ray Judah and John Cassani were really pessimistic that it was not just water quality. Well, here we were able to prove it was grazing pressure. So we got to get to that tipping point. That's the point of me being here today. We have to scale these things up. We have to go at it big to get that grass bed established so that it can withstand the grazing pressure. Freshwater turtles, tilapia, crayfish, apple snails, manatees, everything loves to eat it. That's probably why they call it wild celery. Next slide. This is my buddy Carter Henny and Jim Anderson's patented cage. There's probably several thousand up around the state by now, but they really work. And this is what we're able to grow inside the cage. So just kudos to Carter. Started working with this guy back in 2015. And we did some seagrass. We actually did some seagrass in Boca Grande at the marina there. Some restoration work there. Next slide. I have the cool job. I get to quantify the bugs and fish that live in these grass beds. So seeing Shoreline has scaled this thing out. They do it on an industrial scale. So I'm no longer transplanting the grass myself. I'm able to come in and look at aquatic invertebrates and fish. We're also looking at nutrient uptake, sedimentation rates, and water clarity. Next slide. Just to give you a quick sample here. Okay, so these are the three sites that we did the plantings at. I just want to show here. These are the fish community. These are the various fish species here, and planted and controlled. Okay, we wanted to separate out. Okay, as an artificial reef, these cages are going to attract fish. Small forage fish are going to go there to get away from the big fish. Okay, so we're just trying to figure out how do we discern the attraction of the grass bed versus the attraction of the cage. So we did a side-by-side comparison, and you can see all the planted cages, fish were much more abundant, except for one species, the Seminole killifish, which is more of a pelagic species. It's not really attracted to structure, so it's out there swimming around the river. So it was actually higher outside the cage, or in a cage that didn't have any plants. Just to give you an idea of the attractiveness of the grass beds is there. We did the same thing with invertebrates. I'll skip that slide, but the invertebrate diversity was off the charts. Next slide. Back in 2018, Sea Shoreline and Angler Action Foundation. Actually, I got to tell you this story because this is how crazy. I wrote these proposals, very scientific, all kinds of citations. This, sent it in for funding. No dice. Years I tried this. I get a call from Carter one day. Says, Dave, we got $1 million. I'm like, what? We got $1 million to plant tape grass in the river. You're kidding me. He says, who are we going to run it through? I said, what do you mean? He said, we got to run through either a city, a county, or an NGO. I don't know, Carter. County couldn't take it. County said, we've already got our list of projects funded by the state. We don't want to risk losing those projects to get this $1 million. The city turned it down. The city manager didn't like it. He thought it would attract too many manatees and result in speed zones, increased speed zones. And if we couldn't get water quality credits for it, it wasn't worth doing. So, dang it. So he calls me back. Dave, we got to find, we're going to lose it. We got one day to find somebody. So I call Pete Quashis. Pete's hooked up with everything, you know, Audubon, Snoopy Game Fish Foundation. So I called Pete, we got this. Can you guys do it? So we get back to you. 10 minutes later, he calls me back. We're in. That's how it all started. Now, Snooky Game Fish Foundation, run by Brett Fitzgerald, is now, here's Brett. And here's Carter, myself, and Heather Fitzenhagen at our kickoff event. Angler Action Foundation, they changed their name because when he lobbied in DC, nobody knew what snook was. So Brett changed the name to the Angler Action Foundation. People get that. So I'm all about partnerships, and we had this partnership together, you know, private, public, academic, and NGOs all working together on this project. Next slide. So phase one of this project included 3 sites for planting. Later on, we added a control site down here to look at, these are the planting areas. This is I-75, that's site 1. Site 2, Havens Island, and site 3, what would you do? Next slide. So Johnson Engineering, where I work now, we had our survey group go out there and map the benthos, and they call it hydrant surveys. This is site one. This is called Buzzard Roost Island. It's right below I-75. And this is the depth profiles. The green is 2 feet. This is 3 feet. This is 4 feet. Next slide. This is Hayden's Island. We did the same thing up there. And this would determine where we were going to plant this stuff, because as everybody knows, there's a lot of tannins, a lot of color in the water. And we can only plant it to be 3 feet, 3.5 feet, maybe is the limit. Next slide. And you see the same thing here. So this really determined where we were going to plant. Now, in the previous study, we found that wave action was a real problem. It was uprooting the plants. So we found these areas where quiet water existed. We thought we could plant there and we'll do pretty good. And it did. It did quite well. The problem was the sediments were too soft that the roots couldn't stay established. When they get grazed on, it would pop them up. And so we found plants floating inside the cages. Next slide. These are the nursery grown plants that Sea Shoreline grows at their nursery. The rusky. So these are the plants that are put inside the cage, peat pots. Correct me if I'm wrong. Brian Brushwood's here with Sea Shoreline. He's going to jump in a bit. And these are what they call the Jeb units. I think they called them Jeb because Jeb Bush was governor at the time and they were trying to.
Jim's environmental boat.
Yeah. So Jim's environmental boat, the Jeb units, are planted with this wheel. It's an automatic plan. I think I have a slide over here. Go ahead, next slide. Yep, there it is. There's the Jeb boat. And during the kickoff event, we demonstrated how the plants were installed outside of the cages with the wheel. So this wheel, they plug them in and it just turns as they go along, and plants going every few feet. Next slide. These are the cages for that study, phase one. There were 500 cages, 150 at one site, 350 at the other site. And then at Buzzard Roost, we didn't use any cages. Next slide. This is what they look like. This is a cage taken from Kings Bay, just to give you an idea. This is about what, 2.5 feet tall, 30 inches or so.
Yeah, 28 inches tall.
28 inches tall. So you can see the plants are coming up out of the cage there. It's really a successful method. I've worked with large cages, 6 meter by 2 meter, and these really work nice because they're portable, and you can pluck them up and move them, and they are anchored with the iron ring around the outside. Next slide. So now moving forward, this is July of just last year. This is at Buzzard Roost. I decided to put some cages out there just to see what would happen, because we had grass growing, but it was very short. And look at this. These are 3.5 feet long. These are fully grown Vallisneria plants. This happens to be a strain that came from Hyacinth Control. We call it Green Wave because of Fort Myers Green Wave.
Okay.
It's a wide bladed variety. It does very well. We know it's endemic to this area. Next slide. So this is what it looks like. Inside the cages, we actually see the grass growing so dense. So it's not only rooted in the bottom, but you can see the rootlets here. It's growing hydroponically. You lift that cage up and this big ball of grass floats. It's crazy. So when people tell me it's all about water quality, I say, well, look at this. This is 3 years of planting. And this is what we've got. This is outside the cages, pre-Hurricane Ian. This is what we had. We had about 1 acre of grass beds established at Buzzard Roost and at phase 2, which is a small study just on the north shore of the river. Next slide. After Hurricane Ian, we went out and did some recon work, and we found grass again inside the cages, doing quite well. Very sparse outside the cages. I'm really concerned about this, but that was a catastrophic event. They're saying now it was a category 5. The grass is still there. We need to continue to monitor it as we go into phase 3 and 4. Phase 3 and 4 has been funded by the state of Florida. How much? 3.5 million or something. There's going to be over 1,000 cages at several sites. Let's go to the next slide here, move forward. So this is where I'd like to Brian to come in and talk about this, but again, funding from the state of Florida, we're looking for match from the feds. Either to do research or to supplement the funding from the state. It's already permitted by DEP. We're waiting for the Corps of Engineers to permit it. They're, knock on wood, that we should get the permit fairly soon. Again, it's administered by the Angler Action Foundation. They're going to be finding over 1,000 exposures at several locations. It's expected to begin May or June of this year. Research and monitoring by this new company called Ceilley Aquatic Science and Ecology. Anyway, that company, we're only working on restoration projects. I'm really proud to say that. Most people that get to my age, they retire. I'm going into this new phase. I'm just going to work on restoration projects. Picayune Strand, Kings Bay, Caloosahatchee, and looking forward to presenting next time from under this label. We'll be working very closely with FGCU, my good friend, Dr. Wynn Everham, and James Douglas, hopefully, will be working with us on this and funding graduate students. So that's the way we get things done with partnerships. These partnerships work, and I'm going to turn it over to one of my best partners right here. Okay, Brian Brushwood.
Thank you. What'd you call Val again? It was the orphan stepchild.
Yes.
I do like that. No, as Dave said, my name is Ryan Brushwood with Scene Shoreline. I'm a project manager there, and we'll be managing this Caloosahatchee project. Yeah, you can go ahead and go to the next. I think this is the only slide we have showing it, but I have the numbers here to share. As Dave said, we are planning on starting this summer, pending the Army Corps permit, which, fingers crossed, right, should have some. There will be over 225,000 planting units going into this footprint. These areas were chosen. Who was it? It was Hoflicker that mapped the SAV occurrence. Excuse me. So they were chosen mainly based off of historic SAV occurrence, specifically Vallisneria occurrence in the river, as well as sediment type and depth. Obviously, light availability is huge. I mentioned the plants will be grown out in Ruskin and brought down here shortly. There's also over 1,000 herbivorous exclusion cages that will be used to kind of keep those grazers off of the plants. They'll be kept in the water for 36 months, and they'll be maintained every other month during that period. And so the point of the maintenance is to just make sure, you know, the lights are, or the plants are getting what they need, they're getting light, make sure if there are issues that we're recognizing them early, and we're able to adapt and hopefully overcome those issues.
Is that between the 75 and 41 bridges, or?
Yeah, so for reference, this is I-75 right here. So almost all of the sites are within a half mile of I-75.
West?
Yes, west, only 3A there is still on the east side of it. And so with that, I mean, salinity is definitely a concern. Part of what we're doing to try and overcome that is using different ecotypes that are, you know, really catered for restoration, catered for this area. We have a salt tolerant variety. Sorry. Trying to fight it, but
Salty dog, right?
the salty dog, that's right.
Yep.
Yeah, we have a salt tolerant variety. We have a variety that's conditioned to low light environments as well. A couple other varieties that will be used for this project. Timing wise, we anticipate it'll take somewhere between 8 to 10 weeks to get all these plants in the ground. There'll be a team of technicians and biologists out there the whole time. And as Dave mentioned, there'll be a pretty detailed monitoring that's not only, you know, in place to look at the health of the plants, the growth and survival, but also to look at the fish communities, the invertebrate communities, the epiphytic communities, and how they respond to restoration. And so that's kind of just like the, you know, quick run through of the project. Happy to answer any questions, or Dave, please jump in if there's anything I left out.
No, one of the things that in my scope of work for the monitoring, I've been asked to modify it a little bit. We're going to be doing some underwater video deploying underwater cameras to determine who's grazing on it at different times of the year. So we have video evidence to present in a couple of years. We know who's eating and we know everything's eating it, but there's a seasonality to it.
Yeah, and really what we've seen, I'm sorry, one
ahead,
more
no,
thing
go ahead.
is through these pilot studies and through these previous planting events is it's really not just like one rate limiting factor. There's really a combination of things. It's grazing, it's absolutely salinity, light availability, things like that. And so the goal is to try and address and eliminate as many of those as possible. One of them being, figuring out what exactly is grazing on these plants. And if we can identify that, how can we specifically target to eliminate that? And so, it's large scale restoration. I'm sure there's many factors that will pop up and hopefully we will be able to adapt and overcome those. Good question.
Yeah, do you have an estimated tipping point of when you'll have enough grass that it's healthy and sustainable enough that you won't need the cages anymore?
Mm.
Or cages in perpetuity?
I don't. I'd be lying if I said I did. What we saw in phase 2 was after about 6 months of having plants in the ground, the plants outside of the cages did reach a canopy height that was similar to those inside of the cages. And that phase 2 is just a 2-acre plot. I think a lot of that had to do with, pretty stable conditions in that it's
Showing that.
yeah, phase 2 is.
And then did that survive or did that end up getting grazed down?
So it was growing to about 6 inches until Hurricane Ian. After Hurricane Ian, it did get sheared off quite a bit. There's also a layer of mud that was deposited throughout that area. And as Dave said, we're still monitoring it. There are plants that did survive, but they have not gone back to that canopy height or that density that we saw before the storm.
I'm assuming tape grass flowers. I mean, you mentioned the importance of seeds, does flower,
I
okay.
skipped over that, but I threw this thing together pretty quickly, this presentation, that I could get deep into the weeds on that, but.
Are you gonna-
They're dioecious plants, so you have to have boys and girls, you have to have male and female. Now, the male flower is down at the bottom of the plant. So grazing pressure is not as impactful on that. However, the female flower is on this big long stalk that goes up to the surface, and the plant is actually pollinated at the surface. And those seeds that I passed around, they produce like a whole green bean size a pod that's full of those seeds that can, like I said, they can persist for decades.
Are you gonna monitor that then? I mean, that would be cool if they start doing that on their own.
Absolutely. What
Can we
we
go to slide 8, by the way? There's a picture of a female flower.
yeah.
Yeah,
Which side?
actually, I have to interject because we did the CHNEP. I know that you're aware of this, Dave, that we funded a project, the seagrass gardening, citizen seagrass gardening project back a few years back. And we worked with Sea and Shoreline and we planted the salty dog variety between the 41 and 75 bridges behind people's homes. And it was really interesting because what happened was kind of the worst case scenario. We put the exclusion devices over them. We used volunteers. We went out. It was a lot of fun. We were out there planting them and then we put the exclusion devices over them. And then we were hit like a week later with like this record blue-green algae outbreak that just went on and on and on for months. And we couldn't have volunteers do any monitoring. I know, Sea and Shoreline, I was talking to Carter all the time. We couldn't maintain the cages. Because it was just like microcystin and toxic, stuff. So we were like trying to figure out what to do. We had to just leave it alone. And that blue-green algae went on just for months. And so by the time we were able to get back in there, I was feeling pretty pessimistic. I mean, to your point, Dave, I think, people did raise a lot of concerns about like water quality and we certainly understand that we still need to focus on reducing nutrients and improving water quality. And we also need to get at that salinity issue because sometimes we're pushing these systems outside the envelope of what they can, be sustaining. But anyway, long story short is we went back in, we threw GoPros because I don't think it was safe yet to even like really touch the water, but we threw GoPros down and we have footage. It was unbelievable. It was the first case of flowering seagrass in that portion of the river in over a decade. We actually saw we had the video They were actually reproducing, shooting up their little flowering structures. There were fish, like everything had moved in and taken hold of the little seagrass, installation. So it was really a message of hope, like, wow, like in the worst conditions, these things can sometimes, with a little help.
What were the dates on that? When did you do the plantings and when did you finally go back?
We have a whole fact sheet on this on our website.
Like roughly, just like what?
2018, probably
I
about when the
think
plantings went in.
2018. It was like the same
Yeah.
time that Carter did that you guys did that upstream one, I think the same year.
Look at the headings on these slides. Planted June 22nd, 2015, flowering by October. I mean, that.
Oh, for that installation. Yeah.
There?
Citizen Seagrass.
Citizen seagrass one. I'm not sure.
We went like a year later and they were still.
There are still some plans for safety.
Oh, they're still there.
It's really important for these restoration projects that you plant both male and female plants. Otherwise, you're not going to get that flowering. You get colonization, you have runners spreading and vegetative reproduction, but you won't get seed production, which gives us that resiliency. So we do have an event. Salinity, like for example, after the shared adversity discharges and the cutoff flow, salinities went up above 20 in downtown Fort Myers. That's what wiped out the bulk of that. The 1-2 punch of the algae bloom followed by the salinity envelope. So anyway.
Yeah, and the height of those cages, the 28 inches, is specifically to allow those female plants to flower up, ideally to the surface on a low tide. That's a picture. You can kind of make it out there. One of the female flowers sticking up. Like Dave said, the male flowers are on the base of the plant and release pollen, which floats. And but getting them to a density to go to seed that's a huge part in reaching that tipping point for sure.
One of the things I like about tape grass is it grows so fast that it's, I worked with Thalassia. I grow slow. And it takes a long time to recover if you're doing crop starts. This stuff is amazing. If you go to Kings Bay, you can see what's happened up there. It's just acres and acres of colonization outside these cages. It's a little different down here. Water clarity is a problem, salinity, but with the C43 reservoir being nearing completion next year, we'll have some water that we can release if we do have dry events. And so there's other restoration projects going on upstream. The Lake Hickachee Phase 2 will be under construction probably in the next couple of years. Phase 1 is already completed. We've got water storage projects all over the watershed. Anyway.
The question for you, Dave. Are there any theories behind what caused that the major the flourishing of in 1993, because Vallisneria hadn't been really, like south of I-75, no one had seen it for what, I don't know, 10, 15, 20 years or something. And all of a sudden in 93, it just exploded and it was everywhere.
Yeah.
And it was so noticeable. What were the conditions? Are there theories why it thrives so well from like nothing to so much so quickly?
I don't know that anybody has the answer to that, but talking to Bill Hammond, environmental Bill, he's been around forever. He said back in the 60s, Vallisneria was all the way down to Shell Point. So there was a seed bank in the system that may have been, it can only come back so many times, but there was a seed bank. And so the conditions are right. I think it just pops up.
Okay.
It goes so fast.
Yeah, it was like overnight. It seemed like it was like, it was everywhere.
Yeah, it's a good question.
I was doing, we were doing some mullet research at the time there. And it was just amazing to drive through there and just to see the transformation. The year before there was nothing. And then like a year or two later, it's just completely every shallow place, every island, every bank, just everywhere. It was just unbelievable.
Yeah. Well, hopefully we can get back to that point where it becomes more of a nuisance that we have so much of it. One thing we've seen in a lot of places, including Lake Trafford, we had did a planting with Dr. Everham years ago, in 2008, with some students when I worked at FGCU. And we had 73 acres of algae, and it was crystal clear water. And it's growing on top of mud, growing on top of muck. And so it's very tolerant of different sediment conditions and eutrophication. And, Lynn Geddes has done a lot of work with various, what she calls ecotypes. And the variety that they're started working with is this rock star, genetic senator Widow. She's looked at it. Identified 40 different strains in Florida. Just in the samples, pretty much every watershed has its own unique strain. But anyway, that rock star variety was very tolerant of nutrient-rich conditions and mucky sediments. So it works in some areas. I think using different varieties, different strains is a good way of hedging our bets.
Absolutely. And we do put together quarterly updates, agency updates, once this project starts, and that'll continue for 3 years. So if anyone's interested on progress, we can certainly share those.
You mentioned, you showed a slide and you mentioned this idea of hydroponic growth.
Yeah.
Of some of the root material that's growing like in the water column.
Yeah.
So one of the things I've been trying to kind of figure out is in Kingston.
Yeah.
We see a lot of growth of Vallisneria in areas that were not planted. So
Right.
it's basically spreading. And I've been trying to figure out what is the major mechanism by which these plants are spreading out.
Yeah.
Do you think that's a major way in which you can start to see growth, other than obviously runners proximal to the cages? But I mean, we're seeing
Right.
stuff
It's
in Kings
jumping.
Bay
It's
that's
jumping.
way
Yeah.
on the other side of the bay.
And we saw this in Lake Trafford. There was an event, it was in 2009, Tropical Storm Faye came through and dumped 17 inches of rain in a couple of 2 or 3 days. And the weight went up almost 5 feet overnight. Now, we had these beautiful grass beds out there. And the water level came up, and what it did was these plants released. They have like this little root roots, you see, and they send off these runners, and there's a separate little plant growing with roots and everything.
Yeah.
They release those and they start floating, and then we call
them floaters.
sleep, creep, and leap. Carter calls it. But
I mean, just based on observations, it seems like when the plants reach a certain density, especially in a cage where they're kind of confined to that area, and they start to compete with themselves for sunlight, they will release, like you saw in that picture. And I don't think, I think it's a tactical, strategy by the plants, because the rhizomes will go from white to green, similar to what Rupia maritima will do. Suggesting that even the rhizomes are pulling sunlight and photosynthesizing. So it's super fascinating. It could be a third reproductive strategy. of
Yeah,
these
I've never
plants.
thought about that. And that might that's why they have that competitive advantage when they just spread like weed.
Dr. Geddes is convinced that that's exactly what they do, whether it's light, it is light in both situations. One of them from increased water levels, water depths that these plants are releasing. Little satellite plants are setting out there to go find a place that's suitable. And in Lake Trafford, we really saw it where all of a sudden the exposed shoreline was dense with grass. And I'm like, how did it get there? Our cages are 100 meters over here.
Yeah, that's what I
And so
always
that
wondered.
That's our conclusion, is that we send out these little satellite
Yes,
plants.
and just numbers wise, for phase 1 and 2, we did monitoring and maintenance every 3 months. And we would always pull those floaters out at the top of cages, just so they don't prevent sunlight from reaching the rooted plants. And there were several, like 3-month periods where we would remove upwards of like 2,000 to 3,000 plants and replant them throughout the area. So they're producing a lot of biomass. It's super fascinating how they do that.
It happens really quickly too. Just last year, about this time, we went out and I was out there with a student employee that was working with me at GCU, and we pulled these things out and we got that ball of stuff out. And we went and planted them, put the cage back, came back 2 months later and it's full again. So it was, it happens so quickly. It's encouraging. I know Dr. Geddes wants to consider the listing Vallisneria americana or Neotropicalis as an algicide. And I think that's brilliant. I mean, we should be planting this stuff in every canal.
Well, and it's interesting you say that, because some of the earlier work that we did in advance of when St. Crystal River came into Kings Bay with Sea and Shoreline, we did some of those experimental plantings in Hunter's Cove. And one of the things that
enclosures,
in those big fenced areas. And one of the things we hypothesized was that, the first thing that's going to come in is all that limbia is just going to come in and cover it. We found the opposite to be true, that as those grasses started to grow in, the amount of filamentous algae went way down. So there seems to be that effect that if you can get the valve to grow in there, it'll control the algae.
Chris and Dave, thank you so much